Cool, so quiet. Hello, my name is Yanni. I am the founder of Eternity, and I'm going to talk about smart contracts for smart lawyers. And first, a little bit about myself. I also call myself the godfather of Ethereum. I hope you can read it, because I was early involved in Ethereum, even before there was a name for it, essentially. So I was working with Vitalik on another project on a colored coin wallet. I created even about 7 wallets. I can't even count them anymore. So browser wallets as extensions, as web wallets, colored coins wallets, multi-signature wallets, which are especially secure, and yeah, and other stuff as consultancies and stuff. So I'm pretty experienced in the blockchain space. I worked in the field since 2013. So quickly about what a blockchain is. I also call it a crypto notary, or generally the Bitcoin blockchain would function as a crypto notary. It enables the internet of value, and Satoshi also calls it distributed timestamping service. That's the main purpose here. So maybe we do a quick demo. So I need to go. A blockchain demo. How does this work? Oops, doesn't show it. I need to put it here. Great. I hope everybody can read it. I can make it bigger though. So we have got here a blockchain, and I'm gonna mine now a block. You see the blocks. So this is a block. This is a block. This is a block. The block has a number, has a nonce, has some data, has a previous hash. This is the first block, so the previous hash is just 0. And it has got a hash. And now when I press mine, it's going to mine. While it's mining, I'm going to explain what the nonce is for. Why does it not work? Maybe reload. I guess you are mostly lawyers here, right? Cool. So maybe I start even earlier with a hash. What is a hash? So you have some data, and then for every bit, every time you change something, a uniquely generated number gets generated, and you can't guess from the number what's the content. So when I go to a block, it should actually become green. Oh, now it's green. Okay, the colors are a bit weird from this perspective. Is it green? Okay, cool. So this is a block, as I showed earlier. Let's maybe just go to the blockchain. So every time, so what's special about here is that there's a difficulty in the hash. So the difficulty is essentially defined with a number of leading zeros with the hash. So usually a hash is a completely random number. It has no specifics here, so there's no special amount of zeros. So, but the more you do, or the more hashes you do on a block while changing something of this block, this nonce, so this nonce is changing, you see all the blockchain gets invalidated because the connection between the blocks via this hash gets broken. So when I mine now this block, it will become green, and you will see that the nonce changes and that some leading zeros appear. Cool, now it fits again, but yeah. So usually in a blockchain there are also tokens or accounts. So here are some numbers and some people. So in Bitcoin, these are hashes of public keys, not names, but the next generation of blockchains will definitely support also names. And what happens when one link breaks? For example, here in the second block, when the name is a little bit different, you see the rest of the blockchain invalidates, including everything else. So you need to calculate all the hashes again, and this way it makes it, it's impossible to essentially change the data of the blockchain without doing all the work again. So when I mine, this is really mining. Okay, and something happens. Okay, So a crypto notary enables the Internet of Value. Bitcoin got founded or got created in 2009. I mentioned this already.
What happens if you mine? What happens with the old blockchain? Is it stored somewhere else?
Whoops. The old blockchain. Well, what is the old blockchain? So
You said it's broken now.
Yeah.
That implemented it. Now you mine, then you have a new existing functioning blockchain again. So what
Right.
happens to the unamended version?
So the correct blockchain is defined by the most amount of work which got done in order to build it. Usually,
An orphan block.
huh?
You would create an orphan block or so if you.
Orphan block?
Yeah, a single one that remains as such and will not be continued, right?
Exactly. This can happen. I can even demo it to you here. So what is an orphan block? When I change something here, for example, the nonce, here from this branch of the blockchain invalidates. When I mine now this block, this is a valid block in a bit, but it's not connected to the second block. Or it is connected to the second block, but the second block is not connected to the first block, right? Here's the previous hash. So this is always the same, the hash here and here. And again, here and here. And you see it's valid because the difficulty is matching. The data is supposedly validated as well. And this would be now, one could say, an orphan block.
Okay, but what if I go back to the very first block and amend that one, and then I mine, then I have a new chain?
Yeah.
But the old one may be the real one. So I've kind of, in terms of
Hard fork or whatever yeah. But you can see it. I mean,
Okay.
if you fumble around, you can always see it. That makes it so auditable.
So I would recommend you to Google for blockchain demo. It was on Hacker News a couple of days ago. It's pretty fresh. I didn't build this myself, but I think it's a really nice way to illustrate how a blockchain works with proof of work. So this is a proof of work blockchain. It's very important to have proof of work in a public blockchain in my eyes. But I need to continue because I'm running out of time. So, okay. So I've mentioned this, and what is a smart contract? So smart contracts are nested inside blockchains. Essentially, one could call them, or there are programmable value transfer. You have some rules, some input, and it can't be corrupted. So they simply run there, and they're trustless. This is very important here as well. So, yeah, and they're written in code and enforced by the blockchain. So the network and the blockchain, they make sure that these smart contracts are correct and very easy. Wait. What are paper contracts? So one step back. Paper contracts are essentially manual value transfer. So you write down the rules, and then you have a counterparty or multiple counterparties, and then all of the counterparties are supposed to fulfill the contract. What happens if the contract doesn't get fulfilled? Then it gets enforced by the court system in an ideal world. It's not perfect, but essentially one of the parties goes with a piece of paper to the court or to a lawyer, like you are, and says, yeah, I got scammed, and then the process starts, and it takes a long time and costs a lot of money, and it's very intense. So, yeah. But usually, what's really important here is usually it's just that the smart contract doesn't get, or the paper contract doesn't get shared with all of the world, like it is, for example, with existing smart contract blockchains, such as Ethereum, where everybody who runs an Ethereum node downloads all the contracts and all the code and all the state of these contracts and validates them and executes them. So what would be a digital equivalent to a court system? So yeah, maybe a crypto court. And yeah, so we see this as a way how we can essentially scale up with smart contracts. So we put smart contracts inside Turing-complete state channels, and only in case of disagreement, these smart contracts get written on the blockchain and then executed by the network. Usually just the counterparties would execute it, but it's still trustless in a way that every time you do a step here, it gets signed and then broadcasted to or sent to the counterparties. It can be this way. It can be highly parallelized, and only in case of disagreement, yeah, again, it gets written on the blockchain, or in case of the settlement. So you open up a state channel, you transact according to the smart contracts rules, and for example, if the counterparty disappears, you take the last state, you send it to the blockchain with the part of the smart contract which is relevant here. You don't need to publish all of it, and then it gets executed and enforced by the blockchain. So it's very, very efficient. The comparison here to do smart contracts on-chain, so everything on-chain, doesn't scale obviously. So really imagine every time you write a contract, you need to share it with all the other lawyers on the world, and they need to save it forever. And
It would be just a little bit more specific. Like
yeah.
For example, if I buy a car from you
Yeah.
and don't pay you, how does the blockchain enforce this?
So you write a contract which says that when you receive the car, you send some tokens of value. So somehow it's a bit difficult with a car because the public doesn't know about what you do with this car or what got done with the car. But for example, a really good example would be, for example, election results. So you could have a smart contract which, or let me come to this in a bit because I need to explain what an oracle is. Okay. Maybe I simply explain what an oracle is, but the comparison is also important. So, yeah, the digital crypto court would scale or does scale. I say would because it's not built yet, and essentially supports infinite transactions, only limited by the speed of light. It's also easier to write smart contracts because these smart contracts don't depend anymore on all the rest of the blockchain. It's just among the counterparties. Okay, now I hope this will make it more clear now. An oracle is essentially a way how the blockchain and the network can interface with the real world's information. For example, election results or football games or weather or anything which is public, known in a decentralized oracle, to be honest. And a simple oracle would also work in the case which you mentioned. So decentralized oracle, yeah. Okay, let me explain what a decentralized oracle is. So in how we do it is that everybody can ask a question to the network, and everybody can opt in to answer this question. In case you opt in to answer this question, you need to put down a security deposit. There will be essentially a market for people who want to bring the truth of the outside world into the blockchain system. And this way, yeah, so in case the truth is true, in case everybody believes this, there's no problem here. In case there is a problem, then somebody could come and put down the same security deposit. So there's now somebody is lying, and there is some money to take or some incentivation for essentially for the global network or of the consensus, for the people who participate in the consensus to determine who is wrong or right. So when you have this social agreement essentially above that this blockchain is made in order to interface with the real world, and the tokens, I mean, if you it's essentially like a self-fulfilling prophecy. So you say that Yeah.
Maybe I have an example. Maybe you say, if we do a bet, two of us, that in Berlin tomorrow morning, 8 o'clock, it will be -2 degrees. So, and we put this on a smart contract on a blockchain basis. So the oracle would then be the thing that says us it's 8 o'clock and it's -2 degrees. So, and this is always the source of insecurity, so to speak. Because, I mean, if this is agreed by everyone, if this is, say, like the authority says it's 2 degrees, it would be fine. But if we now have this bet about 10,000 euro or whatever, and maybe we disagree because you say, well, the temperature was taken on the tree, and we did not agree that it's located on the tree. I wanted the ground temperature. So you always have this element of legal insecurity. Same with your example, if I buy a car from you, I mean, what can the smart contract do? Basically nothing. If I claim that the car is not working as it should, what about the smart contract? Nothing. Cannot foresee it, cannot enforce it, cannot do anything. So we have to be clear about this, what can be done and what cannot be done. And with the oracle thing is like, if we have no dispute about it's -2 degrees, 8 o'clock at that location, if this is clear, then we will never end up in court. But if this is not clear, so this is the basic problem, the oracle is the problem. Do we agree that the information that is put into the smart contract that kind of leads to the execution of whatever we have foreseen in the contractual framework? If we agree on this, then we are one step further. Not talking about undefined legal terms, which of course computer technology can never solve. But this would also be an oracle, right? So I understood that like this bet looks fine, looks like the perfect example of a smart contract, like self-executing, -2 degrees, I win, -1 degrees, he wins, but it's not like that. I mean, if we disagree about the oracle, then we end up in court. Yeah, so this is basically what I see from a legal perspective, what's the issue about the oracle. But if you come with the consensus mechanism, like we have in Bitcoin, like you ask the whole world, what do you think, what was the temperature like? Then you have this 50% plus X decision that the majority said it's -2, kind of checking the oracle and agreeing on that consensus.
Right, very, very well explained, thank you. So some good applications with a decentralized oracle would be event contracts on the weather or on games generally, prediction markets on essentially, you trade prediction, peer-to-peer, information market, essentially another word for prediction market, insurances, betting, I mentioned this on sports and games, elections, financial derivatives, contracts for difference, so-called stable.
In the States, huh? They're prohibited in the States.
I don't know, we don't have in the States. Actually, I think most of the value will be generated in the third world countries with blockchain technology. We have already a quite good system here, but they don't have much, so in case they adopt it, they have a way higher incentive to adopt it quickly. And they don't have much regulation there about this. Stable coins are essentially tokens which follow the price of, for example, gold or Bitcoin or any other currency or asset, and many more. But to come back to you, an oracle does not really help much in case you have just a dispute with for a physical object in the real world with just one counterparty. You need to have essentially an intermediary here, trusted intermediary, or several trusted intermediaries like who function as escrow, so that they take the money first, you get the car delivered, and then they check whether this got done. So the car can't really be on the blockchain as long as it's not smart, so that it also can autonomously interact with the blockchain and knows itself knows who is inside and who is driving and who is owning it, right?
It drives off if you don't pay.
Yeah. Okay. Cool. So let's get back to one problem of existing blockchains. I think in the talk before, got also mentioned the scalability, right? Ethereum and Bitcoin with the current design cannot really scale because everything gets shared with everybody who participates. So 7.4 billion people require really lots of transactions, and then there's the Internet of Things coming, which will require probably a magnitude more of transactions. And so we have been working on solving the scalability issue, not just this, but also other. But this is one of the main things here in our new blockchain, which we're doing. And we say that we have infinite transactions per second, which are really just limited by the speed of light. You can have parallel state channels, and counterparties can transact with the speed of light as long as they have tokens, as long as they don't have run out of money. Yeah, we are called Eternity, and the slogan is the Oracle machine because we built a decentralized Oracle. Let me maybe quickly explain what an Oracle machine is in theoretical computer science. It's a construct which can give you answer to any question, even questions which can't be computed. Right? So it's kind of a magical concept. Pretty cool. We build a decentralized Oracle on a global scale. This will be interesting. Now, who is behind this? No. Doesn't scroll automatically, I'm sorry. It did at home. Scrolling down to the team. So I founded this, and I already said a bit about myself. Zach Hess is leading the technical implementation, and also lots of ideas are from his side. One could even say that he invented the concept of a state channel. He is definitely a thought leader in this space. He is American, currently in Europe, and his first coin was Basic Coin, got over 300 stars on GitHub. The goal was to create the smallest blockchain which is possible, which is a very beautiful thing from a computer science perspective. Then he worked also for Augur, which is also a decentralized Oracle built on top of Ethereum. Just that, it doesn't seem to be easy to build useful applications on Ethereum. I guess there might be something wrong with this. Then there's Jack Patterson. He was working for Cinerio, where he wrote a language to write smart contracts in. He helped us also to write the white paper. So we three wrote the white paper last year. We published it about 6 weeks ago. We grew meanwhile. Marion is doing marketing operations. He has experience in the Silicon Valley, also with the crypto crowds there, but was working more for the government. Then Vladislav, he is, I think, the co-founder of the Bulgarian Bitcoin Association, a long-term Bitcoin blockchain community member, and very active in this space. Nicola is helping us, or doing lots of business development and also strategy. Has experience in lots of different countries. Leo is here. Leo, our legal advisor. Louis Chang, our creative advisor from London. And yep. Let's go next slide. No, it did scroll. Whoa. Yep. So what is Eternity? Again, it's a scalable platform or blockchain for smart contracts interfacing with real-world data. And we have a little experiment here going on. We will distribute paper wallets which contain so-called AEA tokens, which are so-called IRC20 tokens on top of Ethereum. Lior, where are the paper wallets? So everybody should get such a piece of paper, or actually two pieces of paper. One is a little description, and the other one is the actual paper wallet with the key. Who has Bitcoins from this crowd, or who has any crypto tokens? Or let me ask like this, who doesn't have? So the majority doesn't have. So this might be a really interesting, use, or let's say first crypto tokens. Now you have, essentially. Now you have. Everybody has. This is the smart contract address. I can demo in a bit how to actually use this. So there's a private key and a public key. Please keep the private key private. It's a bit hard to scan in. I'm sorry, the quality of the printer was not perfect, but you can also just type in the private key into the wallet. It's only a bit long. So this is the smart contract address. You can follow every transactions which you do in the future with this. With these tokens, you can follow them on the public Ethereum blockchain. So Ethereum is really great for having tokens. So this is essentially the killer use case for Ethereum to create tokens and to transact them globally and publicly in the world. Let's see. So we are also a sponsor of the hackathon. We will award a certain amount of tokens to the first, the second, and the third place. Just that I don't know the exact numbers at the moment. I need to speak again with the organizer. You should really keep these papers, especially the winners of the hackathons, because we will exchange them to the so-called AE tokens of the Eternity network 1-to-1 as soon as they start existing. So right now they don't exist, but we are working on this. I wanted to demo you a smart contract or demo you how to use this, but I'm running out of time, I think. So, we have time? Yeah. So stuff like checking your balance and yep. Okay. So this is website myetherwallet.com. It's an open source JavaScript web wallet, which does not load at the moment. I'm connected though. Yeah. So you need to go to send ether and tokens. You need to import the private key to copy and paste it here. Yeah. Anybody who wants to display their private key in public?
Will this also work in this? Will this work within this wallet also?
Yeah, okay. I think somebody will steal now this private key as soon as we use it, but the problem is that I can't really scan it in so quickly from my phone. And so, yeah. I need to skip the demo, I think. But if you go to berlinlegaleternity.com, then you will find, after today, not right now because it's not there yet, you will find essentially a simpler way of using this without all the other stuff. And you will need to, I can just explain it maybe verbally, you need to copy and paste your private key in here. And then what you need to do is to you need to copy and paste as well as another thing, this so-called contract address and the so-called ABI. The ABI is the interface, so that the web wallet understands the binary code or the blockchain code that it makes sense here. One second, how can I demo this? Okay, I guess I can just simply copy and paste here. I'll remove this on the screen. Whoop. Wow. Yeah. Well. not so easy to operate. Okay, I did it. Yeah. So you see here, I just logged in with a random private key of yours. I should delete them after this talk. You see here a balance in ether. This is not the interesting part. The interesting part is the tokens. So right now it's not displayed, the AE token. We need to add it. You will probably not need to do this. You will, because I will make it automatic. But so generally, in case you want to use it again, you need to copy the smart contract address. Here. No. This address. Type in the token symbol. Decimals, I think there were 3. Save it. And now you see AEA. I've got. Okay, I have the decimals wrong. It should be 1250 as written on the paper, and now you can use them. You can transact them among each other. So, yeah, have fun with these tokens. And as I said, we will exchange them to the real eternity tokens after we have them. So. Yeah, I would like to end my talk with a quote from Steve Jobs. Or do you want to see how to transact them?
Yes.
Or, yeah? So you can type in the address, the public key, which is also written here. So decide the amount which you want to send. It's not Ether, but AEA tokens. And this you can keep like this. And then you send it. I will try to send it to myself. Generate transaction. We have a little problem here. So we funded them with Ether and as well with AE tokens, just that I guess we did the math wrong. I consulted with Ethereum professionals, but we still got the wrong number. You see, it's a bit still very, very beta everything, and there will be bugs, definitely, in case you dive into more than just the upper layer of the technology. Then you will see things going wrong or mistakes being made. So the problem is that we have these tokens, but we don't have enough ETH in order to pay for the transaction fee. So the idea was that we also have Ether on this so that you can make at least 4 transactions. I can fix this after the talk. I can send you more Ether to this, but not right now. Okay. Then here's a quote from Steve Jobs, which I think really fits nicely. I'm an optimist in the sense that I believe humans are noble and honorable, and some of them are really smart. I have a very optimistic view of individuals. Why is this important for blockchain? The technology empowers people. It gives them sovereignty over their finances, also over legal contracts or other contracts which can be put on the blockchain, as well as, for example, identity, which is also kind of a contract. So you could, for example, help people who are refugees to document their misery or their path from Africa or Syria to Germany, and this way prove that they're really the people who they are to be or who they claim to be. And also, I mean, we have it really good here in Germany or in the Western world, so we don't have much to fear, but I think most of the world, or the majority of the people, live in suboptimal conditions with a government which is, or a system which is, kind of oppressing them or taking their basic human rights. Even the largest country in the world is kind of, strange in this perspective. So, please join us. We are active in more than 10 communities, Slack, Telegram, Bitcoin Talk, Skype, WeChat, QQ, all these social media platforms, as well as IRC for developers, hashtag Eternity on Freenode. And please also follow me on Twitter. NOYYY is my handle, or Eternity. There's no E and no I in the middle to make it a bit shorter. If you want to stay in touch with us or stay updated. And that's my talk. Thank you for listening. Cool. Any questions? No questions?